Good morning all. Today we will discuss about input and output characteristics of common emitter configuration. Now see the figure. Here emitter is common for both input and output, right? Here this voltmeter reads base emitter voltage and this ammeter reads base current. Similarly here this voltmeter reads collector emitter voltage and this ammeter reads collector current. Okay, now see here, first in case of input characteristics are plotted between input voltage versus input current, right? Here VBE is the input voltage, right, and IB is the input current by maintaining output voltage as constant. Okay, these are the input characteristics of common emitter configuration. Okay, initially set VCE is equals to 0 by adjusting this VCC. Okay, when VCE is equals to 0, this input junction will act as a normal PN junction diode. Okay, then it is in forward bias. Okay, then VCU value is equals to 0, the current flowing through the diode increases like this. Okay, same as diode. Okay, next case, VCE value increases to 5 volts. Okay, we can increase this VCE value is equals to 5 volts by maintaining this VBE voltage as constant. Okay, now see here, then collector emitter junction is in reverse bias. Here collector emitter junction is in reverse bias. When it is in forward bias, this is in reverse bias, right? To get conduction of this diode, what happened? We need more amount of base emitter voltage. If we increase the base emitter voltage up to certain point, then only the current flowing through the base is increases. When compared to here, it requires more amount of voltage to conduct this transistor. Okay, that means if we increase the VCE voltage, the characteristics will shift from left to right in case of common emitter configuration. Okay, these are the input characteristics. Okay, next we will see about output characteristics. Okay, see here, output characteristics are plotted between output voltage versus output current by maintaining input current as constant. Here output voltage will be VCE and output current is IC by maintaining input current, that is IB, as constant. Now see here, VCE is the output voltage and IC is the output current. Here we are maintaining input current as a constant. Okay, that means output characteristics are plotted between output voltage versus output current by maintaining input current as a constant. Initially set IB is equals to 0, right? Increase the collector emitter voltage, okay, in steps and note down the corresponding collector reading. Okay, repeat the above step for different values of base current, then the characteristics will shift. That means the graph will shift from downwards to upwards. This is IB is equals to 0 microamperes. Here it is IB is equals to 20, 40, 60 microamperes, 80, 100. In this way the curve will be shift from downwards to upwards. Okay, those are the output characteristics of a common emitter configuration. Okay, next we will discuss about common collector configuration. Okay, in this common collector configuration, now observe this figure. This collector is common for both input and output, right? Okay, now see here, VBC is the input voltage or base collector voltage, VCE or VEC is the output voltage or collector emitter voltage, IB is the base current or input current, IC is the collector current or IE is the emitter current or output current. Okay, now see here, from this figure, same as previous cases, input characteristics are plotted between input voltage versus input current, right? Here VBC is the input voltage and IB is the input current. Okay, now you can see here,